Danny.
I'm Arthur Gunn.
This is our 201 end semester project, which was the active filter and audio spectrum.
The objective of this project was to use low and high pass filters in order to control lights that responded to an audio input.
As you can see from the schematic, this circuit is broken down into three main subsystems. The amplifier subsystem, the high and low pass filters, and then the triac subsystems.
The first subsystem is the amplifier. This takes in the audio input and amplifies that signal 4 times and sends that signal to both of the filters. The amplified signal is needed because the input amplitude is too small. Here this waveform shows channel 1 across the input to the amplifier and channel 2 across the output.
The second subsystem in our circuit consists of 2 filters, one high and one low pass. Both filters are second order Butterworth. That means each will attenuate frequencies at negative 40 decibels per decade. Doing this, we're able to separate both high and low frequencies from the audio signal.
The third subsystem consists of 2 identical circuits, one for the low pass filter and one for the high pass filter. The triac is used as an AC transistor, which allows for either light to turn on based on the output of the low pass or the high pass filter. The optocoupler allows for the high voltage circuit to be separated from the low voltage circuit while still allowing each circuit to interact.
The first step of this lab was to construct the 2 filters, the low pass filter and the high pass filter. The high pass filter to turn on the one light and the low to turn on the other light. We first did this by scaling the low pass to 200 Hz and the high pass to 1000 Hz.
The next step was to build both lighting circuits. It was at this point we noticed that both the high pass and low pass lights were staying on for too long. We corrected this by rescaling the low pass to 80 Hz and the high pass to 1500 Hz.
Originally, our audio output would not turn on our lights, so we needed to implement an amplifying circuit. This gain allowed us to increase the amplitude of the output of our audio source. We also moved all of our original circuitry on a breadboard into a through board to clean everything up, and then we mounted that on the back of our box.
To successfully power the components in the circuit, a positive 12 source, negative 12 source, and ground was required. This was accomplished using 2 12-volt power supplies connected to a common ground here.
When the optocoupler receives 1.7 volts from the filters, the triac switches on and turns on the lights. Here we see the output of the 2 triacs. This shows the lights turning on and off with an input voltage of 120 volts AC. Channel 1 represents the top light, linked to the high pass filter, and channel 2 represents the bottom light, linked to the low pass filter.
These are the Bode plot simulations. From these, we were able to calculate from transfer functions for both the high and low pass filters. Using these transfer functions, we were able to calculate the cutoff points of the low and high pass filters and scaled the low pass to 80 Hz and the high pass to 1500 Hz.
In conclusion, by using the theory behind low and high pass filters, we will be able to create a functional light show.